Hello everyone, welcome back to the Game Engine Development Workshop series. So today we're just going to wrap things up. We'll write some very simple player and camera scripts, and then we will finish out our scripting language with the spawn instructions, so we can actually have our player create new dynamics and shoot them as a projectile kind of thing. But before I do that, I wanted to go over something that you probably already caught, but I left these like the float versions of these basic math instructions. I had the args as all integer types, and so it was like giving you incorrect errors if you tried to use these. So just basically replace I with f and mi with mf for addf, sub, mul, and div. Okay, so I think we'll get a player script going first, and then we can do a camera script, because there's not much point writing a camera script if our player isn't moving. Our camera doesn't need to move either. So I always like to start the scripts with a main label, even though in this case it's not necessary because main is it happens at the top of the file here, so that would be the natural entry point anyways, but I don't know, I always like to do it. So the first step is, well, I guess we should look at how the script is going to be called. So in our main file here, our player is this new character class. Sort of go down the chain here. Character is just a dynamic, and it has this script called move. And then dynamics have this function called run scripts. And run scripts are called called on every dynamic, every frame, as like the first part of the drawing process, kind of. So in dynamic list.update, the first thing we do is run scripts. And looking a bit deeper into how the script is run for a dynamic, well, it calls scriptable.run, because dynamic, if you remember we changed last time, is now inherits from scriptable. Scriptable.run is over here, and it calls script.run. So on all of the scripts it has, for a character that's just going to be one script, the one called run, or the one called move. So for the move script, it'll call run on that script. It'll give this script runtime, which is not important, and then it passes itself as the host. And that's important because if we want to be able to control our character, we need to know which object our character is. And in this case, because the script is being called from the character is the host. So on all of our instructions that operate on objects, we first load the index of that object into this special obj register. And host, of course, that register stores the special index, just -1 of the host rather than some object in the environment. So the first thing we'll do there is bind the player. I call this binding. I think of it kind of like OpenGL, where you have to bind an object to this target. Okay, so now that we've done that, we can actually get some information about our object and then also write out new information to it. But the first thing we'll do is just get the movement states. So we'll start with x-axis, I guess direction, and we can do that. There are two ways we could do that because we have two commands. We have the is key pressed, but then we also have this sort of convenience one, input key pressed, and this is input key difference. This will take in two values and return the difference in their key states. And that's perfect for this because x-axis movement direction is just state of the D key minus the state of the A key. So we save on a couple instructions here. Just do D minus A, and I'll put that in T0. Then we can do the same thing for the y-axis, just this time with W, so 87 minus S, which is 83, and I'll put that in T1. Now, for convenience, we should move these values into a vector, just so that we can operate on both of them at the same time. So we'll like create a move direction vector. Move in T0, which is the x-axis, to the x spot of V0, and T1 into the y spot of V0. Okay, now these values are going to be -1, 0, or 1. And obviously, if we just like write that out to our player's velocity, they're going to move really slow because it's just -1 or 1. And so what we need to do is get our character's speed and then multiply this vector by that speed. Because this is just directions, like it's not anything to do with the magnitude. So now we need to fix the magnitude. So we'll get player's speed. It's the OGS instruction. Load that into a float register. And then we'll just multiply our vector, V0, by that speed. And then finally, can set player's velocity to whatever value is in that vector. Okay. So if I run this now, we should be able to move around just as we could before. Everything was hard-coded in our main function. You can see we can. It's excellent. So I can move around the screen, but the camera doesn't follow me, obviously. One thing I will say about this this style of like just multiplying the velocity by the player's speed is that obviously that does not account for the case when you're moving diagonally, which if you remember in our main loop, when we were moving diagonally, so moving on both axes, we would divide the magnitude by square root of 2 to make sure that the magnitude of our vector was the same no matter which of the 8 directions we were moving in. In this case, we're not doing that, but because we're multiplying by speed, which is like the maximum speed that this thing can move, that actually is taken care of automatically by this setVel function, because this does the velocity.clamp, which makes sure it's in the correct range. And again, because we are multiplying by like the maximum value, this clamp will always work. But if you were multiplying instead by like speed over 2 or something, then you would have to do the sort of normalization of that vector yourself, which isn't too terribly difficult. And the reason it's handled by setVel is because if we look at OSV, that's the function that's called here, current scriptable.setVel. Okay, so we've got our player moving around. Next, we should write our camera script so our camera follows the player around. So the camera is a little bit different. If we look at this, not character, if we look at camera, it is also a scriptable. And it just has a single script called run. And here is the important line. So run, as we saw earlier, will sort of go down the chain until this object is passed as the host. So we know that this camera object will be the host. But then importantly, we actually do have an environment vector here that contains something, unlike the dynamic, which is just an empty environment. But for camera, we always send target, its target dynamic, the thing it's following, as part of the environment. And the reason we need that is because in order to change our camera's position through this script to like follow our player, we need to have access to our player's coordinates. We need to know where it is. So the first thing we'll do is bind the target, which will be, instead of this, which we had in the player script, because our target is not the host, the camera is the host, our target is the first and only object in the environment. So we'll move index 0 into our object register. And then we'll just get our target's position with OGP. We'll store that in V0. Okay, now that we have our target's position, we can set camera's position such that target appears in the middle of the screen. Same thing we were doing before, which is just take our target's position, multiply it by -1, and then set our camera's position to that. So at this point, we do actually need to bind the host. We need to bind the camera because we're trying to set the camera's position. And then we need to multiply our target's position by -1. Doing -1 dot there because that's sort of our hacky requirement for making this a float immediate. So we now have the negation of our target's position, and then we just need to write that out to our camera's position with object set position v0. Okay, so this should now be running every frame. And you can see, as we move our character around, the camera follows just fine. Okay, so that's like a basic script there. I honestly don't really know what more you could do with the camera. I suppose, again, like depending on the kind of game you're making, you could have it so that if you like walk near the edge of the world or something, the camera like won't go that far. It'll sort of like clamped within the world so that it never displays anything out of bounds. Like you wouldn't see any of this red background. And that would be a little more advanced, something you could do in the camera script. But not something we're going to do. For us, this is fine. We're just testing stuff. But we can do a bit more fancy stuff with the player by setting its state. Because we have this object set state instruction here, which just reads a string from memory and sets the currently bound object state to that. Because our scriptables all contain a map of strings, so that's the string it'll read from memory, to something, some void pointer, some abstract state. And for dynamics, which is what our player is a character which is a dynamic. Those states are where is it? Those states are sprites. So we can actually change our character's state based on anything. Like in our script, we can just have some strings loaded into memory and set the state however we want. So what I'll do is we'll have two separate states, one called move and one called idle. And if our velocity is equal to 0, we'll set the state to idle. Otherwise, we'll set the state to move. So to do that, we will actually have to go back to our main file and create another sprite here. I'll call this S1 and this S2. So S1 will be just test, and then S2 will be test2. And we'll rewrite this a bit, so we'll have a state called move, which will be S1, and we'll have another state called idle, which will be S2. And then we'll set our current state just by default to idle, but it doesn't really matter. Okay, now within our player script, we can check if our velocity is 0, and if it is, we'll set to idle. Otherwise, we'll set to move. So if our velocity is equal to 0, we will jump to a label called set idle, which I'll go ahead and define down here. And this will just do object set state idle, making sure that it matches up with this here. And then otherwise, so if our velocity is non-zero, we will do object set state move, again making sure that it matches up with this one there. And then in this case, we will need sort of a label at the end, which I'll just call set end. And that, of course, needs at least one instruction after it, because if we set to move, we don't then want to just immediately go and set to idle, because then it would always be idle. So if we do set to move, we'll just do an unconditional jump to set end. So this is a typical sort of like if-else structure here, where if our velocity is 0, set to this, otherwise set to this. Okay, so that should be everything we need. So when we run now, when I'm not pressing any keys, my player is just sitting there. It should be this sprite. When I move, it'll change to this one. And the cool thing here, actually, because these are different size sprites, is you can see that just sort of a weird side effect. Like the hitbox resizes appropriately because our dimensions are like refreshed every frame to match the current sprite. So that's pretty cool. But it's not super practical. So I think just for fun, I'll go ahead and like make a paint, like a better sprite here. I don't know what this should be. Let's just make it like a square with an X in it. I don't know. And so if we are idle, we'll just have this basic black square. Otherwise, we can make it red. Okay, so I'll save this. In here as, oh, it's got to be a bitmap. I'll save this as idle. Just fill that as red. Oops, I overwrote it. Okay, that's idle. But then red, go to save as. And this will be move.bmp. Okay, so now I can change these here. Let's see, S1 is used for move, so that should be res/move.bmp, and this should be res/idle. And those just have one state, or one frame. Now if we load this, it should make a little bit more sense. Somewhat more sense. So this isn't obviously like a complete system for handling movement states, because likely what you'd want to do is, depending on the direction that you're moving in, you would want to like have a different sprite. So going back to paint, I can sort of illustrate this. Well, let me close this down because so you'd want to have like a different sprite for if I'm moving up. I might have like an up arrow, and then we sort of have this 8-directional movement model. Where these are all the possible directions. So you have straight up and to the right, and then all combinations of those. And this is more difficult to achieve with our current like instruction set, because really each one of these would have to be a separate sprite, which means that you would have to have like a bunch of separate states. So you would have like move up, move up, right, or something like that. And really, it would be easier to enumerate these in some way, where you could say, okay, this is state 0, this is 1, 2, da 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 da. But even then, it's kind of difficult because all of this is done using strings. And so you can no longer just say set state to move. You would have to have this string in memory and then sort of go to that location in memory, and depending on the direction you're moving, append some number to it. So this can no longer just be move, it has to be move 0, move 1, move 2, and so on. And that is certainly not impossible with our current, like the instructions we have right now. It is tricky though, and it's sort of messy. There's like a lot of magic numbers involved, because what you end up doing basically is saying like, okay, I have this string move, and I want to store that in memory at some place that I can access it and modify it. And so it's not going to be hard coded anymore. So you would have like the hex representation of this string stored in some int register, and then like or that with the number of the number corresponding to the direction you're facing. So you would have this string as a constant in hex, and then you have in some register, like depending on the angle of this vector v0, the velocity vector, you would have in another register like which state that maps to. So if my velocity is 0 and 1, so none on the x and 1 on the y, then that would map to, like, my direction would be 0, and so on. So you'd have to come up with some function to, like, translate from an angle to one of these numbers, like this fake direction system, and then take that number, turn it into a character, and then append it to this string, and then set the state. So it's not impossible, but it is difficult. And there are a few better ways I can think of to do that that we just don't like support right now, but wouldn't be too difficult to. One is just like straight up adding some string support, like just adding some instructions for getting substrings or manipulating strings, rather than having to go in and do it all like with memory, you know. Well, not with memory, with integers, which is just confusing and hard to read and very error prone. And a second is like adding sort of a two different sections to your script files. And this is how actual assembly language does it. Is you'll have like a .data section and then a .code or a .text section, which is where all your text is. So you'd have like this is all the code, and then in data you'd have like some variable name, like a move string. And you could put whatever you want in there. You could maybe specify the memory address that it's at. And then that would sort of alleviate some of the like magic number stuff I was talking about. So again, like it's not impossible to do right now, but if you are looking to do that, which I think anyone making like any sort of sophisticated 2D game probably wants that type of support, just for movement or different sprites depending on your movement direction. You'll probably want to add on to this language. So yeah, that's like the end, I think, of this basic player script. Just we've got a couple states, which is fine. We can move around. The camera follows us. Now we'll move on to the last part of this, which is the spawn command. So we want our player to be able to like shoot some projectile. And that projectile should be in like whichever direction the player is moving, or something like that. Okay, have our script here, new instruction called spin, and this is a bit tricky. Like it's actually more involved than you might think. So we can create a dynamic via the world.createDynamic function. And we have access to this because all of these instructions functions take in a world pointer, which is supplied here by the script runtime object that's passed to the run function. So we can create a dynamic through that. And if we go and look at that, this takes, well, there's this one, which I don't think we're using, and I should probably delete. But obviously, this is way too much information to pass as arguments to a single instruction. But this one is designed for this, where we just pass in a name, which is the name of a dynamic template, so like a type of item, a type of dynamic, and then just create a new dynamic based on the information that's already there. We also have this bool add, and this determines whether or not the dynamic is automatically added to the world and like creates a hitbox and everything immediately, which in this case, when we're just spawning stuff in here, it should not be added immediately, because our dynamic templates store just sort of like default values for certain things, but other things, like you can see it has default value for speed, like the default state. But position, velocity, those are just going to be initialized as 0. And that could be, 0, 0 there might be something there already in our world, and so we don't want to spawn it in immediately there and like have a collision there that we can't fix. So what we'll do instead is just sort of like create this dynamic, and then once our script is finished executing, so we give the programmer a chance to put this thing where it should be and set its velocity and everything, then after the script is finished executing, then we'll actually add it to everything. Add it to the world, add it to the quad tree, and then it'll be, act as it normally would. We'll create a dynamic, and the type of this, like the string of the dynamic template we'll use, will just come from memory. It'll be a string from memory, just like that, and we'll set add to false. Okay. Next, we will push back this dynamic to the environment. And actually, that should be a scriptable pointer. Because now that this thing, exists, the rest of our script should be able to manipulate it. Then we will, to accompany that, get our special object count register. And increment that, because we now have one additional object. And the important part here is that we'll now use our spawn queue, which was defined way up here a few episodes ago that we have not used yet, which is just a vector of dynamics that have yet to be added. And then at the end of our run function here, so script.run, after all of our instructions have done, we will do just a basic for loop and just go through everything in our spawn queue and actually add it to the world. I'll call that spawned. Spawn.add2. We can get the world. So this takes a root quad tree node and then a dynamic list. So we can get the root quad tree node from the world from our script runtime. So rt.world.map.getCurrentQuadTree. And then our world also contains a dynamic list pointer. Okay. Now, the last part of this instruction is just sort of a convenience thing, which is it will take in, obviously its first argument is going to be a string, but then second argument will be an integer register that it will load the ID of this new dynamic into automatically, just so that it saves you like a single instruction of having to just get that yourself from the object count. And the ID, in quotes, of this is just the index of it in the environment, which will be, it was pushed to the back, so it's now the last element in the environment. So that's just going to be the last index of the environment, which is size -1. And that's all we need. We'll add the description for this, spawn. The first thing will be a string. And the second will be an int register. Okay, now we have that. And I'll go ahead and compile just to make sure everything's good. Seems to be. All right, so now in our player script here, I'll sort of separate these out. So we have movement, we have state, or set state, and then we have shoot projectile. Okay. So we need some like indication that it's time to shoot a projectile. We don't just want to do this every frame. So I'll do that. You could do this with like a mouse button. You could say like if the left mouse is pressed, but I'll just say if the space bar is pressed. So input key pressed space, which is 32, load that into T0. And if this is not pressed, so T0 will be 0, we will just not spawn anything. So that'll be our new like ending label there. Otherwise, space is pressed, so we should spawn a new like a new object, a projectile, a new item. So this will be, I think we'll just start it out as like it spawns right where the player is. So we'll just get, because our player is still bound. This is the only thing we've moved into the object register, so I can just do object get position into v1. Then we can use our spawn command. We'll create a dynamic template. I'll just call it item, or maybe proj. And we will, the register that we'll load this into will just be object. Okay. And so basically this has the effect of creating a new item and then also binding that new item in the same instruction. And then I think that's all we should do, just for now. So this will just like spawn exactly where our player is, and nothing else. So there will be a collision, but again, that's not like the real issue. Like I feel like I did a poor job of explaining why we add dynamics to the world later. The reason is not because like our game will crash or anything if there's a collision that happens. The reason is that we want to give the script a chance to resolve that collision, which it will take multiple instructions to do. But if that collision doesn't end up being resolved, obviously it's probably not desirable behavior, but it's fine. Like it's just, there are two things intersecting and that can be fine. And in this case, that's what we're doing. So I'll add a dynamic template. I can do this at the bottom here with world.create dynamic template called proj. And this takes a list of scripts, which will be empty, a list of states, which will be, I'll just give it S1, doesn't really matter. And then float speed, which we'll say 100, doesn't really matter right now. Okay, so we now have a dynamic template called proj. So this should be able to spawn something. I'm not sure, actually, why is this... Oh, weird. Seems I didn't do a very good job with my regular expression there. String followed by a comma is not a string. That makes sense. Okay, I'll fix that, and then I'll change the like zip file that you can download from the description. That should be like this, but because there's a comma there, it's like saying, oh, I don't know that that's string. Whatever. Anyways, that won't affect how it works, obviously. Okay, so we've got this, and then I hit space. Uh-oh. And got null pointer. Okay, so what does that mean? How could this be null pointer? So spawned comes from spawn queue, so that's cleared every frame. Okay, that seems right. So it seems that create dynamic returned null pointer. That's the only thing I can think of here. Let's just quickly verify that. Yeah. Oh, oh, it even printed dynamic template proj does not exist. Interesting. Let's see why that is. So that error is going to be printed from dynamic bank, I believe. Yeah, dynamic template. That doesn't exist. But it should exist because this is being called, right? See if this prints create proj. Yeah, it is. Huh. Oh, I did that. Oh my god. I did that same thing I did with the quad tree, where I was talking and I said if it does not contain, and I put a not there. So yeah, this is the correct check. Oh my god. Okay, so we can see there, because there are a bunch of intersections, obviously we got cannot divide this, intersecting objects have been inserted. But we can see that whenever I press space here, I do get a new object there. For some reason, it's not following my player though. Not sure why that is. Oh, I'm not even setting its position. That's why. So I get the position of my player, then I create this new thing and bind it, and then I have to actually set position to my player's position. So I put one there, I put one there. All right, there we go. And we can see actually if I hold space and move, this is spawning like a bunch of stuff. And that's because these scripts, I mean, you can see here, this thing is running like crazy fast. And I don't have any like time restraint on this. It's just every time my script runs, if the spacebar is pressed, I'll spawn a new thing. So it spawns, I don't know, that's probably 1,000 or so new ones. And you can see that this has dramatically decreased performance by like 500 FPS. Which, I mean, there's no problem with that. At a certain point, there are a bunch of things, you have to draw them all. So that's just going to happen. But clearly, this is not the intended behavior. So we need some sort of timing system for this. And really, in any sort of complex game, I think it would be best to have like an item sort of system that ties into this, and items have their own scripts, and like characters have an inventory of items. They each have their own scripts and stuff. But in this case, we're just doing it all in the player script. So what we need to do is like set a time limit. Basically, we need to say, okay, you can shoot a projectile, but only if it's been at least a second or 2 seconds or whatever since you shot the last projectile. And we can do that with our instruction here, get time, which I think is actually just called time. Yeah, time. So this will get like the current time in seconds as a float. So every time we shoot, which is here, so I should move this. So this is when we actually shoot the projectile, like at this point, after we know that we are spawning when we shoot one here. So we should get the current time. No, with just time. Load that into F0. And then we need to know when. So we have the current time, and we need to know like the next time at which we should be able to shoot. So let's just say, like 1 second. So this is well, 1 second is 1,000 milliseconds. I misspoke. I think I said this is in seconds. This is not. This is in milliseconds. The time in milliseconds since the program started running. So if we want to be able to shoot every 1 second, we'll just take that value, add 1,000 to it, and store it in like another register, another float register that's not getting overwritten. I think we can use F1 here. Yeah, because it looks like we only use F0. Okay, so F1. Do that. And okay, so we now have every time we shoot, we get the current time, and then we get the next time at which we'll be able to shoot. But this is still just going to happen all the time because the only condition we're checking is that the spacebar is pressed. We also need to check that it's been at least a second, that our current time is at least the time stored in F1. So I'll actually move this out here. So get the current time. And then if this time is less than, so if F0 is less than F1, which is the next time at which we'll be able to shoot, then we also just skip to no spawn. Get the time. If it hasn't been, if our cooldown is not done, we won't spawn. And also, if we're not pressing space, we won't spawn. Now if we run, this should be much more reasonable. You can see I'm holding down, moving around, and it's only doing 1 every second. And these are all dynamic, of course, or rigid would be a better way to say that. So very, very neat. I can no longer, or well, I just can't pass through them. Okay, so that's, something. It's not quite a projectile though, so we should actually give it velocity. But before I do that, I think I'll just actually write proper comments for this. So we'll get current time, don't spawn if not off cooldown, don't spawn, well, only spawn when space is pressed. So then we set, I guess I'll call it a cooldown timer kind of thing. Get player's position, spawn projectile, and then spawn and bind, because we're loading the index into object automatically there. And then we will set projectiles position to player's position. Okay, so obviously it's not much of a projectile if it doesn't move, so we'll also need to set its velocity. And we can just set its velocity to our player's velocity, which is still stored, I believe, in, V0. Doesn't look like we mess with V0 until here, so we'll just set the projectile's position to player's position and velocity to player's velocity. Okay, so now if we run, these things should also be moving, and they are. You can see if I stop moving, it'll be nice to have reference here. That thing is going in whichever direction I am moving when I press space. And you can see eventually they go out of the world and you get this. This isn't great because like if I'm not moving at all, it's still just stationary. But let's make this just a bit better. It's annoying me that it's like the same speed. It should be a little bit faster. So let's take the player's velocity and multiply it by, I don't know, 1.5, and then write that out. So these should now move a bit faster and it'll... Oh no, they don't. Huh, what happened? I'm not sure. Maybe 2? Oh, 2 point. Oh, look at that. That's sweet. I mean, it almost looks like physics. It's not physics. It looks like there's momentum happening there, but not quite. That's really cool. Okay, so I'm not sure why this is not. It seems like the multiplication is not even happening. That's all the way up here. Times. Oh, yeah, okay. That should be working. Let's print out the immediate value. I'm wondering if that's not getting translated right. So this should always print 0, this small v, but then this one should print 2. I'm wondering, my suspicion is that the parser, for some reason, is not getting this value. Oh, that's okay. So -1 is from the camera. But then if I run this and I press space, huh? That's not a very effective way to debug that, it seems. But I noticed something weird here. Looks like it's yeah, I don't know. I just can't even like tell what's going wrong here. We could try just printing it from here, I guess. Okay, so we have 200 and 0. Which should be right, because our player's speed is 100. Oh, I am so dumb. Oh, in the template, in the dynamic template, I set the speed to 100 as well. Okay, let's set that to 200. So that instruction was doing what it says, but then the set vel is clamping that into the right range. So this should now, there we go. Okay, that's, oh my god. Okay, so yeah, this is like still not quite perfect. I'll run this again, just because if I'm not moving at all, it won't, you know, like the projectile won't be moving. So let's think about how we could fix this. So really what we need to do is store somehow like the last direction that we were moving in. That needs to be the direction that our projectile is shot in. So how could we do that? So we need to store like our last velocity. And I think we'll do that here. So in our set state here, jump to here if velocity is 0. So if velocity is not 0, we'll be here. So I think I'll sort of like cache this non-zero velocity into v2. So the last non-zero velocity will be in v2, and then we'll use that instead set that. Now this is tricky because we can't just do that, because then, well, let's see what happens when we do this. Okay, so if I've never been moving, it'll do that. But if I've moved to the right and I'm standing still, it should do that. And this is kind of I mean, it is working because these things are moving at max speed, and so they're being clamped. But really, this is multiplying v2 by 2 every time, and because I'm not moving, this is never being reset. So really, we should do all the multiplication here. So v2 is like projectile velocity. So we'll multiply it there. So just do that multiplication once, and then here, we'll just set that directly, v2. And this should give the same results, but technically correct. All right. See, we can shoot diagonally, and these interact with that wall just the same. Pretty neat. Kind of fun. Okay, so I mean, clearly there's this glaring issue of like this spams everything and cuts the frame rate to like a third when these things go out of bounds. And this is like, I don't know a great way to handle this. I'm gonna sort of fall back to my default explanation of it depends on the kind of game you're making, like what you want the behavior to be when these things go out of bounds. Should they despawn? Should they just stop moving? I'm not sure, and so I'm gonna leave that up to you to handle. And I don't think it would be that difficult to handle, because let's see, the first time they're out of bounds, I mean, you could do it by just like in our quad tree here, you could sort of check within like where would it be? Would it be scriptable or no, not in there. It'd be in dynamic.cpp, I think. Yeah, you could check in this update function here. You could change this to take in a quad tree node, and then check the quad tree nodes like position and dimensions and see if you're within that. And if you are within it, then great, you do everything, you do this as normal. Otherwise, so if you're not within the quad tree anymore, you can just set your velocity to 0, or you can like despawn yourself, something like that. So it wouldn't be too difficult for you to implement. But yeah, I think that's all I had. I'll leave that there. This has been a good experience for me, I'll say. I think teaching is the best way to learn, and so even though I've done some of this stuff a few times before, certainly this helped me deepen my knowledge. And hopefully it was the same to you. Hopefully if you've seen this stuff before, just hearing it explained in a different way or written in a different way, has deepened your knowledge as well. Or if this is your first time, doing stuff like this, getting into game programming, I hope this introduced you to a lot of the low level sort of concepts required for that, as well as just got you thinking about all of the problems involved. Like there's so much work that goes into just even drawing stuff on the screen efficiently, stuff moving around. So even though, as I've said many times before, my solutions here are not perfect, certainly, and probably even not indicative of typical solutions, just because I came up with most of them on my own. I still hope it was valuable for you, just to, again, like just get thinking about this stuff. And if you are, interested in game engine programming sort of beyond this, like sort of taking this stuff even further, I'm always happy to answer questions on on Discord, which is, I think I put that in the description of every video, like my Discord tag or username, whatever it's called. So you can message me there, or you could message me in the just like the general ACM, like our what's it called, the circle, our Discord channel. But yeah, I think the like my final closing remark will be like what I hope you got out of this and the intention of me making this in the first place. Other than what I said, about just introducing you, how that's valuable, and just thinking about these problems, I think the main thing that you should get out of this is that um, I'm just a student, you know. I'm just like you. Hello, fellow children. Um, this stuff, a lot of it, I learned online. Like all the graphic stuff, I sort of over several years I've messed with OpenGL, and I've tried to write my own graphics libraries, and eventually it just by doing it over and over and over again, I sort of came up with a system that worked for me. And then beyond that, the scripting language, it's just like I have experience thinking about the problems involved with game engines, as I'm saying, and so I came up with a potential solution to that and just implemented it. So really, what I'm getting at is that, like, and I don't want this to sound belittling by any means, but with all the resources out there today, like if you want to do something, if you want to write some kind of code, you have some idea, like you can literally just do it. There is the only obstacle is time. Like it just takes a lot of time to learn this stuff and become confident and have experience like hooking all these big pieces together. But there's no way around that. The main thing is just like, if you're interested in something, do it. There are tons of resources out there. If you want more resources for game development stuff specifically, I have many YouTube playlists that I've watched, and websites about OpenGL stuff that I can link you if you're interested. But yeah, that should be, I think, the main takeaway from this is that there is nothing special or magical about me, obviously, or any of this code. A lot of it, like I said, is cobbled together from just resources on the internet, from tutorials I've followed, and then I sort of add my own stuff on top of that. And I think like why that's important, beyond just like, oh, it's cool to have this skill to be able to do that, is like that's what a programming job is having these fundamental skills that you've learned from somewhere. It doesn't matter where. If you learn them on Stack Overflow, if you learn them from YouTube, if you learned them in college classes, it doesn't matter where you've learned these fundamental skills. But those fundamental skills are fundamental. They're not going to be like, that's not what your job is going to be, hopefully, because that would be super boring. Your job is going to be thinking about like identifying problems, thinking about how to solve them, and then being able to use the fundamental skills that you have to cobble together some solution. And really, I think that's why this series would be valuable to people, even if they decide, I don't know, game engine stuff really isn't for me. I think just having any sort of experience with that sort of mindset of identifying a problem, coming up with a solution, and being able to implement the solution, that applies to maybe everything in life. I don't know, that seems like a very general statement, but certainly every sort of programming job. Yeah, so I'll sort of leave that there. I really enjoyed making these, and I will see you at some point in the future.